Alright, Season 2, Episode 11, which is very similar to the early Episode 3 when you look at it. We have an expression for velocity and it wants to know the total distance travelled between t is 1 and t is 4. There's that tricky word distance again. We need to make sure that we get that right. So we do a check of points where the velocity might be equal to 0. So at the point where a velocity is 0, it can mean the change between sort of heading forwards or heading backwards. When it comes to distance, we don't care whether you're moving forwards or backwards. We want the total distance. It's not signed. So just to be safe, before we try and integrate between 1 and 4 to get distance, we are going to check the points where the velocity is 0. So you set 0 to be the equation here. You can factorize t out. There's a t in common through the whole thing, which will give you this line here. T, take t out, you end up with 6t squared, take 3t plus 4. Now that tells us that either t is equal to 0, or this whole lot here has to be equal to 0. Not an easy one to factorize, so I've gone for the quadratic formula. At the front of the t squared is a is 6, b is -3, c is 4. So we go and we write down a quadratic formula that you all know and love. If you don't remember it too well, there's a really annoying, I think it's Wheels on the Bus version of it on YouTube. You can go have a good listen. Anyway, if you put the values in, negative b, so a negative negative, it's a positive 3. B squared, -3 times -3, is a positive 9. Take away 4 times a times c, all over 2a. You've got an issue here. 9 take away that value, whatever it is, 72, that's going to be negative. So there are no real solutions to this particular section here. That leaves the only x-intercept, which is actually a t-intercept in this question, to be at t equals 0. That's fantastic news for us. If there had been an intercept in that range of between t is 1 and t is 4, we would have had to integrate two sections separately to make sure that the positive velocity didn't remove the negative velocity, and yes, it ends up being quite detailed, as you've seen in some of the other questions, if we happen to have a point where velocity is 0 in there. Right, so that's good news. We can just integrate the original formula between 1 and 4 because there's no point where velocity is 0 there. So integrating, in each case, power goes up by 1, so it ends up t4 divided by 4. Ends up being a t3 divided by 3, ends up being a t squared divided by the 2. A lot of this can be simplified. 6 over 4 can simplify to be 3 on 2. Over here we have 3 divided by 3, they cancel, leaving us with just t cubed. And over here 4 divided by 2 leaves us with just 2t squared. From here, standard definite integral process, we substitute in 4, and we take away what we get if we substitute in 1. So here is that whole expression with 4 in it for t. Here is that whole expression with 1 in it for t. Start working it out. 4 to the power of 4, well, you end up with 128 times 3, which is 384 for that bit. 4 to the power of 3, 64. 4 squared 16 times 2 gives you 32. I know, you can just put this in the calculator, but anyway. Here, 1 to the power of 4 is just 1, so it leaves us with 3 on 2. 1 to the power of 3 is just 1. 1 squared is 1, times 2 is 2. If you wanted to be really special about it, you could then sort of go, well, that's 320 plus 32, so 352. Here, that's effectively saying 3 on 2 plus 1, which will give you 5 on 2. That's 2.5. You get 349.5 meters. Now, this was unusual in that you'll see that I went through and already written that example, and that's because I went here and I did a silly mistake right there and wrote 252 instead. How did I realize I'd made an error before I handed it in? Well, I used a graphics calculator because your graphics calculators can all work out the definite integral. You can put that formula in your graphics calculator and check your answers. And you know, when I put it in, it told me it was 349.5 instead of the 249.5 that I had. So thankfully, by checking my answer, I saved myself putting in a wrong answer. Verified by Graphics Calculator. Yay!